Hello, in part one, we talked sort of conceptually about standard deviation and standard error. And so now in this part two, what we're going to do is we're going to look at like how do you actually calculate these things. So the first thing you're going to need is this handout, AP Biology Equations and Formulas. You were given this at the start of the year. It's posted on Schoology. And this is the official document that you will get to use on the actual AP exam. And so what we're going to do is just slowly throughout the course, we're going to go through sections of them and talk about it. So today we'll see, standard error and standard deviation are actually on that formulas and equations sheet. And they look kind of scary, these formulas, but it tells us what they are. S, sample standard deviation. X with the line on it is the mean. N is the sample size. Okay, all right, we can sort of figure this out. So let's get into this. Take a look at this data here. And if you notice the means, they're 11.4 for each of these. And so my question is, how would you respond if someone said that these two trials were identical because they had the same mean? Now, if you look at that data, hopefully you'll notice that the data are not quite identical. Here we're kind of in the 10 to 13 range, while here we got 5 to 17 range. So even though they average out to be the same, these are not similar data sets. So clearly the average doesn't capture the full essence of what these data are showing. So these are not the same. And so what we want is a standard deviation to kind of represent that this has a larger spread than this. And so hopefully, number two, looking at this data, which trial do you think has the larger standard deviation? Hopefully you can see that 2 has a larger standard deviation because it has that wider spread. And now step 3 is to calculate the standard deviation for each trial. So you're going to use this formula, and again, you get this on the AP test, you get this for our unit exams, you don't need to memorize this, but you do need to know how to use it. And the standard deviation, S, is equal to the sum of X minus the average squared. So since there's 5 data sets, you're going to say 11 these are the X's. So X, 11, minus the mean, 11.4 squared. And then since it's saying the sum, you add all those together. So 11 minus 11.4 squared, plus 12 minus 11.4 squared, plus 11 minus 11.4 squared, plus 10 minus 11.4 squared, plus 13 minus 11.4 squared. Okay, all of that divided by n minus 1. N, as it tells you on that sheet, is the number of samples. So since we have 5 samples, it's going to be 5 minus 1. And then you take the square root of that whole thing. And so what I want you to do is pause, please pause. See if you can make this calculation on your own, calculate the answer, and come back. So hit pause. And hopefully the screen is not enlarging. Hold on. Okay, we're back, got it figured out. So hopefully you did your calculation, and I'm gonna go real high tech here, and can you see it? So that's kind of how it should all be written out, okay? So that's 5 minus 1 in the bottom. I know, I should have wrote this neater. So if you calculate that, hopefully you were able to get 1.14. So make sure you can do this, make sure you can punch it into your calculator to get the right answer. And then if you did the second set of data, which I would encourage you to do, you should get 4.77. So again, even though the means are identical, this standard deviation term is now telling us more information. It's telling us that this has a wider spread. That's nice. Okay, now we need to calculate the standard error. And so for this one, which would have the larger standard error, hopefully you would see, well, the standard error is going to be larger here. And so again, we're just going to calculate that. Take your standard deviation and divide that by the square root of the number of trials, in this case 5. And so again, punch in your calculator, pause, make sure you got it. I'm about to display the answers. You ready? Here they are. And hopefully you were able to calculate that. Certainly let us know if you are struggling with it. But that's the standard error. So that's sort of saying that if we repeated this experiment, thousands of times, and we calculate the means, this would be kind of the standard deviation of all of those trials. Okay. So now we need to add the error bars. Now remember, the error bars represent 2 times the standard error. So you have to multiply this by 2. So the standard error, 2 times the standard error would be 1.02. Let's just say 1. And over here, it'd be 4.26. Let's just say 4.2. Okay. So what you do on your graph is you would then say, okay, if we're at about like maybe 11 point, well, we're at exactly 11.4, we would go up 1 above that to 12.4. And then we'd go down 1 below that to 10.4. And that would be our error bar. Here, we would add 4.2 to the top, and then subtract 4.2 to the bottom, and that would be our error bars. Okay, now in Google Sheets, you can do this just using the computer, but that's what the computer's doing. Note that a larger sample size actually leads to a smaller standard error. So suppose you had a standard deviation of 20. Calculate the standard error if n is 16, meaning you took 16 trials, versus if n is 4. And if you do that math, hopefully you'll see that these are actually different. And the reason why is if you have a larger sample size, then we're more confident in the data. It's kind of like if you flip a coin, if you flipped a coin 16 times, n equals 16, you're going to be more likely to get a 50-50 ratio of heads or tails versus if you only flipped a coin 4 times. Okay, so the standard error will be smaller, which is good, a tighter spread, if you have more samples to measure. Okay. So at this point, hopefully you are good on standard error and standard deviation and graphing. So here's a little humor for you. And then finally, here's just a recap. There's a series of videos. These are all linked in the slideshows that you can check out if you want to get a little more info on that. And then here's another little joke. So the rest of today is going to be about going through the following slides with your learning community. So now you're going to use the information I've just provided, and you're going to try and graph your data. You're going to calculate the mean, the standard deviation, and the standard error using Google Sheets. And so follow those directions carefully. They're clear, but you got to follow the steps. Okay, and you're going to record those values in your data table. Determine if you should use a line or bar graph, and then actually graph it using Google Sheets. Again, the tutorial will tell you how to do that. And then finally, for your conclusions, I think you've gone through this in other classes, your claim evidence reasoning. So what is your claim? What did you conclude about the number of drops that is held on the penny? What is your evidence for that? What is your reasoning? Note that for evidence, you're allowed to just reference your graph. You do not need to type out in words every single data point, because both you and your teacher will go insane. So state your claim, cite your graph to kind of do the evidence, and then most importantly, give me the reasoning. Explain why you got those results. And then finally, sources of experimental error. Note that sources of experimental error are not mistakes that you made. So things like, oh, we just counted wrong, or, well, we bumped the penny. When real scientists do science, oh, that was wrong. They don't write up those results, and we shouldn't either. If you bump the penny, redo the trial. Don't just say, oh, I bumped it and screwed it up, so that's why our data's off. No, fix the problem. So sources of error are going to be things just inherent in the experiment or the design that are going to limit what you can conclude. So examples of these that are pretty much relevant for every lab report you'll ever do: number of sample size. Of samples that you took. Did you have a large enough sample size? If you did it 3 times, is that enough? Probably not. You probably should have done it 1,000 times. So things like that are what we're looking for sources of error, and we're going to let you kind of discuss those with your group. So, so again, these slides are here for you to discuss, and I'm going to let you go through and do that. So be sure you're using that document, how to write a lab report, and that lab report rubric to do your write-up. And then you could review one another's work if you like. So those are those science practices we started with. We just engaged in all of them in this process, and hopefully you're feeling pretty good about this by the time we're done. So thanks, everybody.